The AI Institute and McNair Aerospace Center at the University of South Carolina and Fraunhofer USA have partnered to develop an assistant for BMW's material planners. The proposed solution captures, analyzes, and exploits rich BMW datasets to enable optimized and proactive materials controls, optimize specialized human expertise, and reduce line stoppages due to missing parts at BMW. Relevant recommendations and potential challenges are communicated to material planners through an interactive dashboard. The following video tutorial demonstrates the basic functionality and different widgets of this dashboard. If you have any questions or feedback when watching this video or using the dashboard, please send them to the project team at riamatthews@sc.edu. The dashboard has views for 4 material planner IDs that represent a subset of the overall material planners. In the future, the number of possible logins can be increased to accommodate more planners. The different usernames correspond to the planner IDs, which are 114, 594, M11, and 177. In this demo, the passwords for each account are identical to the usernames for simplicity. By having a login page, the material planner has a personalized view of materials that they are responsible to manage at BMW. After logging in, the material planner is shown a health score and summary screen for their respective material IDs. The health score widget tabularizes the material IDs and gives a health percentage from 0 to 100 for each one, with 100 being most optimal. The material planner can obtain the contributing factors of a specific health score by clicking the Show Analysis button. Once clicked, 2 charts provide information about the available quantity for the next 10 days with respect to safety stock. For example, a material with a low health score could indicate that the material availability is low with respect to safety stock. Closing these charts and moving to the Part Detailed Description widget at the bottom allows a material planner to see more granular information for each material, such as safety stock, plant, and lot size. The material planner can have a detailed view of exceptions of each material by navigating to the Exception tab on the left-hand side of the dashboard. Clicking the Exception tab brings up 2 additional widgets. Analyzing them allows for material planners to see what the leading cause of exceptions are, and which materials are responsible for those exceptions. The top widget is an exception manager, which is time-based and provides a graphical summary of the exceptions for all material IDs in the past 60 days. The second widget is materials-based, which summarizes the exceptions for each material. Moving to the Part Ranking tab using the left-hand side of the dashboard, the material planner can see forecasted arrival probabilities for specific materials. Material IDs are selected using the drop-down menu in the top right-hand corner. The top widget presents a long-run approach, which provides a percentage for the material being early, on time, or late based on the performance of a given part in the past. The second widget presents a Markov chain approach for when the material planner needs more granular information about how early or late a material order may be based on the status of the latest delivery. This approach uses historical data to calculate how a part has performed in the past and predict how it might behave in the future based only on their current status. Percentages are given for increments of 1 day ranging from -3 to +3. For example, if the Markov chain shows 8% for -3, that represents the probability for a part being 3 days early is 8%. The final tab in the navigation bar is the recommendation engine. The recommendation engine implements decision rules elicited from material planners. The current rule set recognizes situations where expedited orders need to be made, where certain exceptions can be ignored, or where the recommendation engine will defer to the judgment of the planner. The recommendation engine may also determine that a part has no issues to be resolved. For example, one rule in the decision engine is the zero-out exception 15. This rule is triggered when an exception 15 is found on a scheduled agreement for a part. The rule states that if there are future dependent requirements where the receipt requirement is less than the available inventory plus the exception quantity, Then the recommendation engine would propose zeroing out the receipt requirement of the scheduled agreement having the exception. To use the recommendation engine, a material planner selects a material ID with the drop-down menu and submits a request. The system provides a recommendation that can be accepted or rejected, and the planner can provide a rationale for that rejection using the input box below. Finally, the planner can log out of the dashboard using the last tab on the navigation pane. During this phase of testing, the University of South Carolina and Fraunhofer teams are actively seeking feedback on the widgets and charts used to present information in the dashboard. Additionally, the development teams want to hear from you on ways to make the dashboard more user-friendly and what items users like you would like to see included. Please feel free to explore the dashboard with all the usernames to see how different planners are represented. Again, please submit any feedback to the project team using riamatthews@sc.edu.